Hello and welcome to the presentation for our paper titled UCC-IX, Iris Excellent Large Language Model. The motivation for this work is surrounding the topics of large language model, which has so exceptional performance in a wide range of natural language processing tasks. Recently, they are capable of understanding and generating human-like text. However, most just focus on popular language like English, for example, and there is limited representation for low-resource language, for example, Irish, which is a definitely endangered language classified by UNESCO. The challenge for building such large language model for the indigenous language are first the scarcity of training data and also the scaling law of language modeling, where you need to train billion parameter models. You need to have billion and trillion of training tokens. For example, the Llama 2 model by Facebook or Meta require 2 trillion tokens to train. And this is not feasible for extremely low resource language like Iris, where we estimate the upper bound of all Iris data available at the moment is only in the few hundreds of million of tokens. And another problem is also the lack of comprehensive evaluation benchmark of comprehensive capabilities of large language models like reasoning, question answering, and so on. Here we have a motivated example where the original interaction is in Iris. We ask a question in Iris, and we get the response from multiple different state-of-the-art large language models. The first one is Llama 2 70 billion instruct model. And the second one is ChatGPT, and we compare them with our resulted model, which is UCC-IX. The original question in Iris, when translated to English, is: imagine that you are participating in a race with a group of people. If you have just overtaken the second person, what is your current situation? Where is the person you just caught? Okay, and we can see the answer by either Llama 2 or ChatGPT is totally incorrect and is not relevant to the answer to the questions at all. So this shows the behavior of inherent biases where they just output common phrases in Iris. So even though the answer is in Iris, it does not help with the question at all. Compared to them, our model UCC-IX so excellent answer in both natural Iris and in responding correlated to the question. So in summary, our contributions in this work is an innovative framework for continued pre-train of large language models for extremely low resource language. And we contribute UCC-IX, which is the first ever Iris-based large language model. Our performing much larger model is up to 12% performance improvement. We also contribute to the evaluation efforts of Iris LLMs by introducing some benchmarking datasets for Iris, including Iris QA and Iris translated version of MT-Bench. Our main approach in this paper is about language adaptation through continuous pre-training, where we leverage a large-scale trained LLM on vast amount of data, and we allow the LLM to be productively adapt to understand additional language after training by iteratively posing it to target language data. And we work on the hypothesis of recent work that we can transfer the world knowledge and proficiency in one language to another through continuous pre-training. And before we can train, we also expand the vocabulary of the tokenizer of the original English-centric LLMs to include native Iris tokens. Here we have a sample with Llama 2, where the original Llama 2 tokenizer perform on Iris fairly badly. And compared to that, our attempted version with Iris tokens, the tokenized resource is much more meaningful and also more efficient, which is 1.5 times faster than Llama and GPT models on generating Iris text. And the support units here are also more meaningful. We spend the effort to curate all of the current available Iris data from multiple different sources, and we perform a lot of data cleaning and data preprocessing using heuristics, and also the duplication between data sources using file matching. And the final data set, we believe it to be much larger than on previous works on Iris NLP. In this benchmarking results, we see sustainable improvement on Iris tasks for our large language model, which is the last one in the table, and it is up to 12% improvement to all the large language models. This showcases the effectiveness and efficiency of our proposed framework and approach. And you can interact with our system live at anna.chat. At anna.chat, this is our system for the demo of our large language model, our Iris-based large language model, where you can interact and interact with the large language model by typing and receiving the answers in a conversational manner. For example, I asked a question about how to say hello and goodbye in Iris, and we can see this is the correct word for hello and the correct word for goodbye in Iris. We can continue this conversation by asking another question. What about have a good day? And we can see that the language model can understand from the context that we are asking about how to say have a good day in Iris, and it can return the correct answer. We can also start another conversation, ask it about something, not just a translation task, but ask it to do something for us in Iris. For example, here I have a sample of writing an email in Iris to ask the supplier to buy some item. And his email template returned by the large language model. We can continue this conversation, rewrite the email at that I also want to buy 25 packets of noodles. And we can see the mentioning of 25 packets of noodle in Irish here in the response by the large language model. So this is also the end of my presentation. Thank you for listening, and you can interact live with the language model at anna.chat.